MOISE is a collaborative project conducted by the IRT Saint Exupéry, focused on the aerospace domain. It brings together industrial companies, consulting firms, tool vendors and public research institutes around a common goal, to develop collaborative model-based approaches for system engineering in the extended enterprise. When developing complex systems, partners of the extended enterprise have to exchange and process tons of engineering data, most of which in a text format. Through a greater use of models, the project aimed at improving the efficiency of information sharing between companies and across engineering domains. By providing means to achieve seamless co-engineering, we help reducing misunderstandings, design iterations, and ultimately development costs. The project tackled 4 thematics. 1. How to exchange and aggregate heterogeneous modeling data across the extended enterprise. 2. Ensuring consistency between safety analysis and system definition models. 3. Generation of a co-simulation environment based on the system architecture description. 4. Improvement of the need elicitation using models in a customer-supplier relationship. The development of a new product becomes more and more challenging as design complexity increases and manufacturing demand is high. Indeed, during early phases of the development lifecycle, both the product integrator and the suppliers have to take strong commitments at short notice. To do so, many analyses must be performed based on various data sources. For each analysis, engineers have to identify the relevant documents from many companies. Then, they can start looking for the set of parameters of interest. Finally, if no human error has occurred at any step of this process, the analysis can be performed. Now, imagine that there are tens of analyses to be done on a system with the same set of data. As a consequence, and in order to meet time-to-market requirements, the product integrator and suppliers are changing the way they work together in the so-called extended enterprise. They tend to use model-based systems engineering as a mean of exchange to reach an unambiguous communication. However, the inescapable heterogeneity of data, methods and tools within the extended enterprise leads to the same misunderstandings as with textual documents. MOISE project developed a proof of concept named TP, a collaborative platform mock-up allowing to overcome this. This makes it possible to take advantage of the structuration of systems engineering data, and to achieve a true digital continuity along the development process. This methodology allows improving the quality of each analysis, thanks to the possible automation of input data validation. Incomplete or inconsistent data are rapidly identified, avoiding the risk of getting erroneous results. Moreover, the time required to perform each analysis is drastically cut down by avoiding repetitive tasks of very low added value. Furthermore, such a unified systems engineering data can be used for KPI computation or production of BI reports across the extended enterprise, or even in a landscape of multiple extended enterprises. Several steps are required to reach this status, which were successfully experimented with TP. First, select analyses to be accomplished and their associated exchanged data. Then, map methods and tools of the extended enterprise to the set of analyses. Decide where reference data are stored. It could be centralized or distributed. Choose the relevant access rights for each analysis at a given baseline. Provide federated data to other information systems. MOISE project outcome gives the opportunity to aggregate heterogeneous engineering data, and to constitute a unified vision of structural architecture, while handling confidentiality constraints within the extended enterprise. TP, our proof of concept, succeeded in building a federated view for 2 classes of problems, breakdown structures and interfaces. It opens the way for other analyses like shared resources management, but also for enhanced services for change management. Some locks remain. They will be tackled in future IRT projects. MOISE project also produced transverse outcomes that supported our activities. a study case of a drone for aircraft pre-flight inspection. It is composed of architecture models, safety models and behavioral simulation models, some of which are open source and can be downloaded from the IRT Saint Exupéry forge. A glossary, or more precisely an ontology for more than 300 terms relating to system engineering, constituting a valuable common reference, and is part of our state-of-the-art review of structured databases of 230 ID cards for MBSE methods, languages and tools that can be accessed online by our project members. Thank you for your interest, and do not hesitate to contact us for further information.